Okay, good afternoon, ladies and gentlemen. So, our objective for today is that students will be able to create a table and a graph to examine what happens when a piece of paper is repeatedly cut in half. Okay, so we're actually starting our next unit right now. It's unit 6. It's entitled Growing, Growing, Growing. Right? So, we're going to be studying something this unit called an exponential function. And we're actually going to see later on that it's actually a little bit related to what we were just doing about volume with some of those equations, right? Since they had exponents in them, and we're talking about exponential functions, you're going to find a relationship there, okay? So the scenario for today, it says that Penelope is the secretary of the Student Government Association at her preschool. She is making ballots for a meeting, right? Ballots are just little slips of paper that people vote. It says Penelope starts by cutting a sheet of paper in half, then she stacks the two pieces and cuts them in half again. With 4 pieces now, she stacks them and cuts them in half. By repeating this process, she makes smaller and smaller paper ballots, okay? So this is actually a lesson that I like to do together while we're in the classroom because it's interactive. I give students pieces of paper, I give you scissors, you cut them up, and we're examining how many pieces of paper we have every time we cut it, right? So it's something that actually sounds really simple at first, but you actually might find that the results are a little bit not what you were actually thinking. Okay, so what we're going to do first is you're going to make a prediction. So I want you to write down how many ballots, the ballots again, those are just the little strips of paper that she gets after she cuts it. So how many ballots do you think they're going to be after just 4 cuts? You're going to type in your response here. Then how many ballots do you think she's going to have after 10 cuts, right? So just make a prediction. Doesn't have to involve much math. What do you think, right? She cuts it 10 times. How many papers are there? Now, after that, what you're going to do is I want you to actually try this experiment for yourself, right? You're going to first find a piece of paper. Second, find a pair of scissors. But I'm going to ask that you just get your parents' permission first before you go playing with some sharp objects. Now, the instructions are pretty simple, okay? Follow along with me. I have one piece of paper here. I've got a pair of scissors here. So you don't have to be perfect, right? First step, cut it in half. So I'm not going to be that accurate. If you want to sit down, fold it in half, get really accurate with it, go ahead. So I've got 2 pieces of paper. Now, what you're going to do is you're going to record your results on the table on the back of the page. So after my first cut, you're going to type in 2, right? Because right now you have 2 paper ballots. Now you're going to stack the 2 pieces together, fold them, cut it. Now I have 1, 2, 3, 4 pieces of paper. So every time you cut, you're going to count how many you have. So I have 4 pieces here. You're going to write it on your table. So now I have 4. Then you stack them up on top of each other. You cut them again in half. You count, write it down here, repeat that process 5 times, right? After you do that 5 times, the question next says, is there a pattern in the way the number of ballots change with each cut, and what is the pattern? So you're gonna start to notice that there's a change here. I just want you to explain how are those numbers changing, right? How are they increasing? Try to be as specific as you can. Now, based on whatever pattern that you recognize here, what you're going to do next is you're going to continue that pattern and write down how many you would have for 6 cuts, 7 cuts, 8 cuts, 9 cuts, and 10 cuts. Again, that's without doing the cuts. Based on the math that you notice, how many pieces of paper should you have, right? And then if you want to check yourself, you can actually try to keep cutting it to see what the numbers actually match up, okay? And I also want you to think about it. Do you think it's actually going to be physically possible to cut up the piece of paper that's stacked up after you're at your 10th cut, right? Is that going to be physically possible or not, right? After we're done with all of that, the next page, we're going to take our data that you just made in your table, right? So this is a table. We can see patterns by looking at the numbers, but humans are visual, right? We like to look at pictures. So what we're going to do next is make an actual graph, right? So if we were sitting in the classroom, Mr. Correa would have some graph paper. You'd have to label everything out, find your X values, your Y values, plot your points. It takes a lot of time, right? But we have this technology that we're using now. It's going to make it actually a lot easier. So what you're gonna do first is just identify what's the independent variable. So what's gonna go on your x-axis of your graph, right? And just to help you out, looking at the table up top, I identified for you which is your x, which is your y, right? So you're just filling those in here. Then, if you have not already, I want you to click on this link here. That's gonna take you to the video that I made to show you how to use the online graphing tool, right? It's not that complicated. If you watch the video, it explains it all very well, right? If it still doesn't make sense, I'll gladly help you with it during our Zoom session. Now, after you watch the video, you're gonna click on here. That's gonna take you to the online graphing tool, right? So if you wanna pull this up along with this side by side to help you out, but this is how you're actually gonna make your graph, right? So you're gonna use the data points, right? All 10 of them. So this X value with this one. Here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points, right? You're gonna plot all of those there inside the computer and it's gonna spit out a lovely graph for you, right? Then all you have to do is copy and paste inside this box here. You're gonna have your nice graph that's gonna fill up the table here, okay? After that, the last thing that we need to do today is just kind of examine that graph, look at it, see what we see, okay? So the first question that you're gonna see is, does the relationship between the number of cuts and the number of paper ballots appear to be a linear relationship? So remember, we spent a unit talking about linear relationships, right? We talked about what patterns you see when you're looking at a graph if something is linear, and also if you're looking at a table, what makes something linear, okay? If you don't remember what's going on with the table, the graph part that you just made with that online tool should be very easy to decide if it is linear or not, okay? After you answer that question, try to use complete sentences, then a couple of more, just kind of as an extension. So if you don't get to the last 3 questions here, don't worry about it, right? If you're out of class time, but I would like you to try that, okay? So it says, suppose a Penelope could make 20 cuts. How many ballots is she going to have? So that's not a how many do you think she's going to have, that's how many would she have. So I actually want you to try to work this out. So obviously you're not gonna sit down and cut the paper 20 times, right? You could try to, I might be impressed, but I would rather see you try to work it out with the math. So again, you're gonna see a pattern. The pattern continued down to here. So if you were to continue that pattern down to 20 cuts, how much paper would she have? And then again, if it went down to 40 cuts, that's even more. How many paper ballots would she have? And at this point, you might start to think, is there a faster way for me to answer these questions? Okay, and there is. I want to see if you can come up with it yourself. If not, we'll see it on the next lesson, right? Last question is going to be, how many cuts would it take her to make at least 4,000 ballots? Okay, so good luck. If you have any questions, the Zoom session will be live and active. Good luck.